Okay, so right now we're going to look at finding a missing side in a right triangle when we know a given angle and a given side. So in this case, we have a 65-degree angle, and we're trying to find its adjacent leg, and we know its hypotenuse. So since we're working with the adjacent leg and the hypotenuse, we're going to use the cosine ratio. So the cosine of our angle, 65, is going to equal the ratio of the adjacent leg, which is x, to the hypotenuse, which is 8. Alright, and if we take a look at our calculators, our calculator will tell us that the cosine for 65 degrees has a ratio of 0.4226. So this is equal to approximately 0.4226 equals x over 8. Now if you think of this as being a proportion, think of the denominator here as being 1, then we can cross multiply and we get x times 1 is x equals 8 times 0.4226, which our calculator tells us is approximately 3.3809. And if you were instructed to round up to the nearest hundredth, say, we could say that x is approximately 3.38. Now sometimes we're going to also be asked to find a missing angle. So here's a triangle where the sides are 3 and 4 for the legs and 5 for the hypotenuse. And we want to find our missing angle theta. Well, in this case, since we know all 3 sides, we can use any of the ratios we want. So I'm going to pick the sine ratio this time. So the sine of our angle theta, which we don't know, is the ratio of the opposite leg, which is 3, to the hypotenuse, which is 5. So the sine of theta is going to be 3/5. Now we're interested in finding theta, so what we need to do is get rid of the sine function out here. And the undo for that is called the sine inverse. Alright, on your calculator you'll see it just above the sine ratio. So it'll look like a sine to the -1 power, but we read it sine inverse. So we're going to take the sine inverse of both sides. So the sine inverse of the sine of theta equals the sine inverse of 3/5. Alright? Well, the sine inverse and the sine are opposites. They counteract each other. They're inverses. So they drop each other out and we're left with theta. And now we have to find the sine inverse of 3/5. We go back to our calculator. And we're going to take the sine inverse, so second, and then the sine button gives us the sine inverse of 3 divided by 5. So this, and make sure you put that closing parenthesis. So sine inverse of 3/5 is 36.869. 36.869. So if we round like to the nearest tenth, it'll be 36.9 degrees. Okay, so when you're finding angles, you're going to be using the inverse of a trig function. Let me do one more of those. Okay, on this one we have sides of 5, 12, and 13. And I think I'll use the tangent ratio this time. So we have the tangent of some angle theta is equal to the ratio of the opposite leg, 5, to the adjacent leg, 12. So we know that the angle we're looking for has a tangent ratio of 5/12. So what angle is that? Well, I need to get rid of the tangent. So I'm going to take the tangent inverse of the first side, and if I do that I have to take the tangent inverse of the second side. These undo each other, so we're left with theta is approximately And we'll take the tangent inverse of 5/12. So second tangent, 5 divided by 12. And it gives us 22.62, so 22.6 degrees. 22.6 degrees. There you go.